Now let's talk about another method which you can use to select values out of your list. So we have already talked about this logical operators using in vectors as well. So you can use that same method to get values out of your list as well. Okay. So I'm just going to pass true for that index from which I want to receive the value, and false at those index from which I don't want to receive the value. Okay. So now my list has only 3 members. I have already dropped the first member. So now my list has 3 members. So now I want to access A, but I do not want to access B and March. Okay. So I'm going to pass a vector, and in this vector, the first index I will keep true and the rest index I will keep false. Okay. So wherever it is true, that index is going to be printed, and wherever it is false, so that index is not going to show up in your result. Okay. So let's print this, and you can see it works clearly just like we did in vectors. Okay. And similarly, if I want to receive, get the first 2 values and not the last value, so again I have kept the first index and second index true, and the third index as a false. Okay, so if I try and run this, so you can see I am able to get the first and second value and not the third value. Okay, so this behaves exactly the same as we saw in vectors. Okay, fine. So now we have learned about accessing elements from a vector, and we have also seen how to modify values in a, sorry, accessing value from a list, and also we have seen how to modify values in a list. Okay. So now let's go ahead and check how to add certain values into your list. Okay. So now you have created a list with 4 values and you want to insert more members into that. Okay. So how can we do that? So let's go ahead and use this list only that we have created. So let's print this list. So you can see I have 3 values in my list. Okay. And I now want to get more values added into list. So let's check the length. So length is 3. So one thing you can do now, you know that there are 3 members. Okay. So you have to add a new member at the 4th place, right? If you're going to use any of the index that is already there, if you're going to use like index 2, so it is simply going to modify your list. Like, so if here I'm assigning one value, so if I'm going to use any of the existing index 1, 2, 3, so it is simply going to replace that particular value with this new member, right? That's what we have seen in this modifying values in list part, right? You are simply going to give the index of that value that you want to modify. Okay. So now here I have 3 values in my list, and if I'm going to pass any one of these index, then it is simply going to replace that value. But I want to add new values, right? So where will I add? So 4th index, right? Because 3 are already there, so you want to add, so you can go ahead and give 4. So I have passed the 4th index, and now I'm trying to assign a new member. So let's see if it works or not. So I hope it worked. Okay, because there was no error message, so it worked. So how? Yeah. So how exactly are we doing it? We are passing the new index where we want that value, and then we are using the assignment operator, and I am simply giving the name of the member that I'm going to add. So now let's go ahead and print this. So you can see my new member has been added, and now if I go ahead and check the length of my list, so you can see the length has changed to 4. Initially it was 3. So my new member has been successfully added, right? Fine. Now one more thing. So here we have added at 4th position. So we knew that length is 3. So the new member should be at 4th. What happens if you give 7th or 8th or 10th and the length is 3 or 4, but you are going to add a member at 8th position or 10th position or 13th position. Okay. So what will happen? Will it work or it is going to fail? So let's go ahead and check out. So I'm here, the length is what? 4, and I'm trying to assign a value at where? 7th. Okay. So there is no value at 5th and 6th. So I'm just going to try and assign a value to 7th, and let's see if it works. Fine, it worked. Okay, there was no error message. So what do you expect? What would have happened? So is this number going to be assigned at 5th or 6th or 7th? Okay, and if 7th, then what is the value that is going to be 5th and 6th? Okay, so let's go ahead and check this answer. So I'm now going to print this list. Now you can see the new member is added at the 7th position, but at the 5th and 6th, a null member had been added. Okay, so this is how your list is going to react when you are going to assign a value to a certain index before which there is no value. Okay, so here my length was 4, and at 5th and 6th there are no values. I have not added any value at 5th and 6th, but I am trying to add a value at 7 now. Okay, so my 5th and 6th automatically becomes null. Okay, so this is how your list handles this particular thing. Fine. So now let's talk about different methods which you can use on list. So we have already seen some methods such as sum, min, max, variance, and all of those things in vectors. Okay. So now think about this logically. So a vector is what? Atomic vectors that we have talked about. So atomic vectors contains members of same data types, right? So either you can use integer or floats or numeric in a same vector, and then you can go ahead and use the functions such as sum and variance and mean and max and all those things. Okay. But now think about list. What is a list? So list can contain elements of different data types, right? So what is the main importance? What is the main importance and what is the main difference that segregates a list from a vector? So its ability to store values of different data types, right? So its main purpose, the purpose of creating a list is what? To store values of different data types. Okay. So now if you're going to create a list of just numbers or just numeric data types or just float data types or just integer data types, like similar data types, right? So it beats the purpose of being a list and it is actually working as a vector, right? So there is no sense of creating a list with same elements. Okay. So that's why in R, whatever functions that we have discussed, whatever the methods that we have discussed, which we can use with vectors such as sum and order by or sort or some all those functions that we have discussed. So those methods actually do not work with list. Okay, because the purpose of list is not to give you members of members with same data type which you can sum and which you can get a mean and max out of. Okay, the purpose of list is to create values of different data types. Okay, so if you want to use some function on a particular container, then you should go ahead and create a vector, because anyways you are going to store a similar values, right? If you are not going to get some of a container object or list or vector in which you are going to store numbers as well as string, right? And you are not going to sum those values. So either you are going to store only integer values or float values or something like that. So it's better to create a vector in those cases in spite of creating a list, right? So that's why the methods that we have discussed in vectors, so those methods actually do not work with list. Okay, so let's try and well, let's see what happens. I've created three lists here. So I'm trying to create one list with only integer numbers, one list with only float numbers, and then I'm trying to create a list with integer values as well as character values. Okay, so this is the main purpose of list, that's why you want to use. So these are actually not a very good list, because you can easily use vectors for this, right? So let's try and create this. And now if I'm going to use the sum function that we have used in vectors, what sum does, it actually gives you a sum max. So I'm expecting the value 4, 3, 7, 9, 10. So I'm expecting a value 10 if I am going to print the sum of list 1. So let's go ahead and see if that happens. I am going to print, let's say, sum of list 3. So it is anyways a mixed data type, so it is not going to run. So let's try for list 1 first. And if you run it, so you can see there is an error. So invalid type of argument. Okay, so that means the list argument, your sum function is not expecting list argument. Okay, so this is not going to work with list. So anyways, this is also going to fail. And similarly for order function, if I try to run it, this is also going to fail. Sort function, this is also going to fail. Okay, because these functions are expecting vectors, not a list. Okay, why? Because you can only use these functions when your data type are similar in a particular list, right? And if you're going to use similar data type in a list, then what's the point of using a list? Use vectors, and then you can use these functions on the vectors itself. Okay, so these functions do not work. What works? So there is one function called unlist. Okay, so this function is actually going to convert your list back to vectors. Okay, so here I have created the list 2, and it has numeric data types as well as integer data types as well as floating data types. Okay, so I am trying to unlist this particular list 2. So let's try and convert this list back into a vector. Let's print the vector. So now this is a vector, and now if I am going to use this sum, so it will work fine. So that's why all these methods do not work. So actually there is no method that you want to learn in this particular list. So the unlist method works, and you can always use the length method. So it will work pretty fine with any list. Okay, fine. So let's move ahead and discuss about named list, just like we discussed with named vectors. So just like we talked about named vectors in vector, and we understood the significance of using named vectors. So similarly, you can use named list as well. So here you are just going to assign certain names to the individual values that are present in a list. Okay, so let's go ahead and see how we can do that. So here, if I would not have used the uh, named list, so I would have created this function, this list, something like this. Let's see. So I don't want name here. I don't want age here. I don't want city here. Okay. And this is how I would have created a list one. Okay. So this is how I would have created a list if I have not created a named list, right? So what I'm getting a name, a age, and a city. Okay. So now, suppose this is only three values, and we would have 10 or 15 values, and someone asks you to get the value of, suppose out of these three, let's add some more. So let's say the first name is there, so last name, then age, then city, then job description, then what is the salary of that person, and different personal observations you can add into this particular list. And now suppose out of those 10 or 20 or 50 or 100 items that are present in your list, someone asks you to retrieve a particular item. Okay, so you have to remember the actual index of that particular number, right? If I in these three words, if I ask you to get the city, so you can easily say that the Bangalore is at third index, so I'm simply going to pass third index and I can get the city back, right? But suppose it is a 100-member list, then how are you going to get it? You have to remember each and every index, and you have to remember that, okay, at this index this value is present, at this particular index this value is present. So it is going to be a very tedious task, and you have to actually do a more manual work there, right? So instead of doing that, I'm simply going to assign a name to each of my values. So I'm not using the default index that R is going to give me. I'm not going to use index 1, 2, 3. Instead, I'm going to create my own index so that I can retrieve a value more easily. Okay. So I'm just going to use name for Ramesh, age for 32, and Bangalore for city. And now if I have 500 values in my list, then also I can simply, I don't have to remember the index of that particular value. I just want to remember the what value do you want. So if someone asks me to get the city, I know that, okay, I have saved that particular value with city name, so I'm just going to pass city, and that's how I can give the city value, right? So that's how named list works, and in those cases it is very beneficial. So instead of saving anything like this, I am just going to pass the name as name, the age as age, and city with the city name. Okay, so let's try and run this. So now your list name becomes name Ramesh, age 32, and city Bangalore. And here, if I run this particular list one, so here you can see by default the R is also naming your vector by default. You can say that, but the names are 1, 2, 3. Okay, and now you have changed this custom the default name 1, 2, 3 with your own custom name. That, okay, the first value is name, then age, and then city. Okay, so this is how you can create name vectors, and it is going to be very helpful for you. Okay, and now if I want to retrieve the city name, so I'm simply going to pass this index which is my not default, this is my custom index that I have provided, that, okay, this value should be named as city. I'm just going to use that index, and I've got the value. Okay, so the it is similar to our vector part. So this is how you can create your named list. Okay, and then you can always you can always add a new element to your list by simply using the named method. Okay, so here let's say I want to add a one more member, and that is if the person is working or not. So if not working, then I'm going to assign false. If working, then I'm going to assign true. Okay, so you can simply give the name that my name is working, and I'm trying to I am storing the value true there. Okay, so the new value will be added, the value will be true, and its index will be working. Okay, so let's try and add this. And now if I'm going to print the name, so you can see a new index has been added working, and the value for that is true. Okay, and similarly, you can also add a non-named member. So suppose I do not want this name to be here, so I am going to add a new member, and I want it to be at the default index. So how many values are there? 4. So at the fifth value, I want to have a new normal member with no named value. Okay, so I'm just going to add this, and now let's see. So you can see a new member is also added, but this time it is not named, like not custom named. It is just at the fifth value, and the value is 55. Okay, so this is how you can create named list, and you can add the different members into your named list as well. Fine. And now let's go ahead and see how can you delete values from a named list. So let's say I have added this 55. So I'm just going to call this particular index at which it has been stored. So it is stored at fifth index. So I'm calling the fifth index. So I'm getting the value here 55, and I'm simply assigning it to null. So I don't want any value there. So I'm simply assigning it to null. So let's see if it deletes the member. So you can see clearly that it has been deleted. Okay. So this is how you can delete values from named list as well. So these are the all functionalities that you can do with named list. Okay, right. So this is how you can add members. This is how you can delete members, and I have also tried to explain the working of named list as well. Fine. So let's talk about one more method or function that you can use with your lists, and it is going to be very helpful. Why? Suppose you want to create this named list. So I have created this particular named list, and these are the names of all the members. So instead of calling every time like this, I want to simply print city or name or age, and I want to get the value. So I do not want to specify like this, that okay, from this list get this particular value. Okay, so you can simply use this function called attaching. So you can simply attach this list to the R memory. Okay, so here basically I am trying to attach this list to the R memory. So R will always remember that, okay, what are the named values in this particular case, and you can simply type that name and you can retrieve the value. So let's see how it works. So in the attach function, I have passed that list that we have created, list named, and now first let me print this list name here so that it is easy to understand. Okay, so here my name is Ramesh, age is 32, city is Bangalore, and working is true. Okay, so I have attached the list to my R memory now, and now if I'm simply going to type name, it is going to give back Ramesh, age going to give back 32, city going to give back Bangalore, working going to give back true. Okay, so this is how you can attach a list to your R path also. So R memory path actually. Okay, so this is how you can attach, and you can retrieve the value by simply passing the name of that particular variable. Fine, and then you can always detach the name. So let's say I detach the name, and now if I try to print working, so you can simply say that this object is not found, so it is going to give back an error. Okay, city also the same case, so it does not remember this particular names, so it is going to give you back an error. Okay, so this is how you can use attach and detach with lists. So I hope all the concepts related to lists are clear. And if you have any doubts, just let me know in the comment section, and I will get back to you. And if you haven't still subscribed to our channel, do subscribe, do like the videos if you like them, and do let us know in the comment section. So I'll see you with the next data structure in the next video. Thank you.